So this is why it's really important to not use websites like Promethease for clinical medical data and have somebody that knows what they're doing read your genetics for you. So just to orient you, I'm looking at vitamin D metabolism. I'm looking at the main enzyme that converts the inactive form of vitamin D into the active form of vitamin D, which is CYP2R1. So a lot of studies have found an association between a SNP, so a single nucleotide polymorphism is RS2060793, and a altered level of 25-hydroxy vitamin D, which is your inactive form of vitamin D, not your active form of vitamin D, but it's the one we test. And if you just look at the associations, yeah, it looks like it's significant. But when you take a second to look at the vitamin D levels of people that have this polymorphism, they're pretty much similar. The difference is 4 points, which isn't a lot. And the standard deviation is anywhere from 12 to 13. So this should not be clinically relevant at all. People should throw this out of their clinical reports because while it looks like it is a big deal, it's not. But if you don't look at the data and look to see how it's actually affecting the vitamin D levels of a bunch of people, you won't catch that. And then just for like extra fun, I like to see what the allele frequency is, because if it is a serious polymorphism and we've had enough evolutionary pressure, we should have weeded this out a decent amount to where that allele frequency will go down, meaning not a lot of people have that polymorphism because it conveys an evolutionary disadvantage. So the people that have that are less likely to survive until reproduction. And about 40% of people have the polymorphism allele. So there's obviously either not a lot of evolutionary pressure to change this, it's not that big of a detriment, or maybe it's something with the advent of industry and agriculture that evolution just hasn't caught up yet to making this allele a big deal. But when you go into the Promethease report, it says that people that have this mutation have higher serum levels of vitamin D, but they've even made a mistake with that because they're saying that if you have the G allele, you have higher levels of vitamin D, and it's actually if you have the A allele, if you have higher levels of vitamin D. Promethease gives you so much information, and it's really nice because it compares it to SNPedia in ClinVar, which is the NIH clinical variant database. But a lot of that information isn't good, and it's not medically relevant. It's from associational studies, and the associational studies pick up garbage all the time. So again, the person reading your genetics needs to look at that actual SNP, look to see if we have any studies showing that it's actually causing problems in humans, look at the allele variant, look to see what site on the enzyme, protein, whatever is being mutated and how that mutation is affecting either binding or enzymatic function or translocation ability, or they need to figure out exactly what is going on in the cell to figure out how it's going to affect you clinically and see if that clinical effect is enough to actually cause an issue to bother telling you about it. Because a lot of these don't matter. And I'm not going to sit here and have you read 40 pages, 100 pages of documents if it's not clinically relevant.